Well, good evening. Um, uh, Earlier today when I showed up, I ran into a friend of mine, John, who's here, and we were reminiscing about the fact that he had actually helped set up a seminar at Oso Negro going back now 11 or even 12 years, where I talked about this house with this plaque. And I think that's kind of an interesting thing to think about as we are reflecting on the fact that the kind of lackluster change that we've seen from our leaders, and the fact that we're in a situation of needing to think seriously about adaptation. And Passive House, which I'm going to talk about today, really offers an opportunity for both mitigation and adaptation. So maybe it could point a direction. So what is Passive House? And Passive House is basically an energy modeling framework that guides designers in choices and homeowners and building owners in choices around how to develop their buildings and how to develop the envelope and the systems that support the building in a way that reduces their emissions as much as possible. And now, most recently, also talking about the embodied carbon. A little bit about embodied carbon and operational carbon. For a long time, we really thought that operational carbon was where we needed to put our attention. We really needed to reduce the amount of carbon emissions coming out of utilizing our buildings every day, the energy that we're burning to run them. And about 3 or 4, maybe 5 years ago, it started to become obvious through mathematical studies that the embodied carbon actually is about as important as the operational carbon. And the embodied carbon is the energy that goes into building the building. And as you can see here, about half of those emissions, that's the mining, the forestry, manufacturing, trucking, getting it to site, the energy on site to put it all together. Half of those emissions in the building's lifespan happen out of the gate in the first 2 years of its life. So this graph really is just showing where Passive House sits on that continuum of an old building all the way to net zero, where we're actually maybe being energy positive and producing energy on site. And Passive House itself also offers those classes. My house is a Passive House Classic. We do have the ability, and it's designed to put solar panels on the roof, which is controversial because solar panels don't work maybe as well as we all wish they would around here. But nonetheless, you can, through these different stages, get to a 90 to 95% reduction in your energy use within the building itself, but then also start to produce energy on site and become energy positive. So it's a great framework. And one of the things about that is, if you're going to start producing energy on site, you really want to reduce your loads as much as possible before you start producing that energy, because energy is hard to produce. We use it quickly. The technology is changing all the time, so that technology becomes obsolete, and so you're now swapping that technology out. And it's very impactful in its production, in making the technology. And so by creating a building that has as low demand as possible, now you're able to put in a very small energy production system and have a real impact on the needs of the building and hopefully its community. So how do you produce a passive house? And it's not really that much different than the housing that we're building today. It's just doing what we're doing, but just a little more clever, and a little more of it. And so my own house actually has 16-inch thick walls filled with cellulose. We got R60 walls, R100 ceiling, and the insulation wraps around the foundation. And so, that's the first step, really good insulation. The second step is really good windows, and there's excellent windows being produced throughout Europe, and now they're starting to being produced within BC. That's helping to bring down costs. Your HVAC system should use a heat recovery ventilator, and that basically is exhausting your moist, stale air. As it exhausts it through the fan box, it passes the heat to the incoming cold air, and so at about up to a 90% efficiency. And so you're able to have 100% fresh air exchange through your building, which makes for a wonderful interior living space, and without losing very much energy. To complement that, you wrap the house in basically Gore-Tex. It's a smart membrane You have a layer on the inside, layer on the outside, as opposed to the old vapor barrier where we're creating a plastic bag. This is a membrane that breathes. It allows vapor to move through the wall, but it doesn't allow air to move through the wall. And air carries moisture into the wall, which causes degradation. And so by keeping air from moving into the wall, you keep water out of the wall. Vapor, at the very small, atomized water, can move out of the wall, in and out, just like breathing. And so you never get the buildup. You never get the condensation in the wall that causes the dry rot and the black mold and the eventual degradation of your building. It's a really clever system, and it's actually fairly easy to do. And the last one is thermal bridge-free design. You don't want any large pieces of structure sticking through that thermal envelope, helping to conduct heat in and out of the building and causing condensation opportunities. And that's it, like those 5 things. And so we're already doing most of this. It's just that the software we're using to model it, which is an archaic piece of software, HOT 2000, isn't as nuanced or effective as the Passive House software. And we can get to that 90%, 80% efficiency through Passive House, where we struggle to get there with the software that you're using under the STEP code. It can be applied to any kind of building. We can do residential buildings, single-family homes, all the way up to 30-story towers. We can do institutional buildings, schools, industrial buildings. These 5 buildings, 4 of them are built. They are mass timber and Passive House. One of the projects I'm going to talk to you about is a recent project here in Castlegar, which is mass timber and Passive House. And it's one of just a very small handful of buildings that have been built in Canada. The last one there is an institutional building. That's a rendering, but it is going to get built. And so you can really apply this technology to any kind of building. This is an interesting list. Affordability is going to be probably the most interesting one to talk about here. But why should we try to build Passive House? And it's pretty obvious up here today, listening to the presenters that we've had already and some of the ones coming. Clearly we're here to try to mitigate the potential impacts on the climate. And that really is the first job of Passive House. And I would say the most important job of architects, engineers today on the planet is to figure out how to get there as quickly as possible. So energy efficiency and low embodied carbon is of course first positions. But Passive House offers so many other reasons to consider building that way. Passive House now has been around long enough, and there's enough components being built within Canada and supplied within Canada that you can actually build Passive House. Remember, we're at step 3. So step 3 right now under the BC code is mandatory for residential. We can get to certified Passive House for about the same money. Now, if you're in a really cold climate, it's going to cost you maybe 5% more. And if you're in a bit of a remote location, that could go to 10% more. But the reality is that it just takes clever design and planning and a competent construction team to really basically match the cost of step 3 construction. And as an architect, one of my pitches is that you bring me your budget, I'll design to your budget, we'll trim 10% off your floor plan, you'll never know it was gone, we'll build you a Passive House for the same money as you would have spent on a code level house. And then you'll start living in a Passive House. And I live in a Passive House. And so when I go to visit my friends, whether it's in the Lower Mainland or even here in Nelson, it's wintertime, and we're sitting down, you take your jacket off and you hang it up in the closet and you go and hang out. And I'm looking around wondering who left the door open. Because as you all know, our building stock is relatively terrible and drafty. But Passive House never feels that way. It's always warm. There's no temperature stratification. There's no cold corners. You don't have cold air dumping off the windows. It's really a superlative living environment. Low impact we've talked about. They're resilient. So we see climate change happening. So this is the adaptation part. We now are having smoke-filled summers. The HRV has a carbon filtration on it, 100% fresh air exchange, and because of the insulation, very cool environment inside. It's really, every single Passive House is a haven against kind of, the new smoke season. Not, in addition to being warm all winter and cool the rest of the summer when the smoke isn't around, it offers that opportunity, that respite from smoke when it happens. I've talked about how durable they are because we're not letting water into the envelope. And then if you make some really good choices in your cladding materials, you can, again, have a building that'll last 100, 200, and with good maintenance, who knows. They're very comfortable because of the air exchange that I've talked about, because of the filtration I've talked about. Also, they're incredibly quiet because of the thick envelope and the very excellent windows. And so, I live next to a road out in Blewett that motorcyclists love, and the Harley Davidsons can rip up and down the road, and I don't even hear them. In fact, people come to visit me and I don't know they're there. So that can be a problem, but the living environment is incredibly comfortable, and they're light filled because you have to have sun coming in. It's part of the heating system, and actually there are some human health aspects within the Passive House framework that demand that you have light in all the important rooms where people are spending time, and so this list doesn't do a Passive House justice. There are so many reasons beyond the low impact nature of the building to consider trying to live in a passive house. And frankly, I have done a lot of work for BC Housing, probably 30 different projects of different types of residential solutions for people, both on the Lower Mainland and regionally. And they're a long-term owner, long-term operator. And in my opinion, every single BC Housing project should be mandated to be passive house because they have to deal with that asset into the future indefinitely. So it makes a lot of sense. And also, it happens to be a lot of times the most vulnerable populations that are using BC Housing projects. And so those vulnerable populations are well protected in these kinds of environments. So this is my house. It's a triplex. It's a 2-story building on the front side and then has a walkout basement. There's a bunch of technology about how we got there that I'm not going to be able to touch on. But you can see the solar shading on the south side. This is approaching spring where we want the sun to start shading the windows. And so because of the overhangs and the sun inclination, we're going to start to see those windows go into the shade so we don't overheat. Just as one small thing that you're able to see here. I need better pictures. These are all 10-year-old pictures, but the house is, we designed very small footprint. Again, talking about trying to reduce your overall cost of construction. My house was 600 square feet. My mom's is 600 square feet. My brother had a little more money at the time, and there's some metrics that needed his unit to be larger, so he's got 1,200. But we have an equal amount of covered deck outside because we live out on the decks and in our garden. And so why spend money on that interior space? We put up a lot of storage out on the decks, and it's cheap to build, and you don't have to maintain it, and it's not heated. And so, deck space is invaluable. So we built our tempered environment as small as we could get away with. And here's some of those spaces. I favor a kind of, Danish kind of design, really clean, white, lots of wood. I love wood, very natural. And I try to use durable materials that we're not going to feel like we need to renovate in 5 years because they've, the tastes have changed or they've worn out. This is a house in the cusp. Again, a triplex for a very, this woman was so amazing and so supportive, and she knew what she wanted to create, and she worked with us to create something incredibly beautiful. They're all offset, so everybody gets a little private front deck facing right into their lakes. And it's a combination of some really nice, beautiful local wood, but also some fire smart steel. And then they've got these separated garages that create this kind of a environmentally buffered space in between the garage and the house where the entrances are. And the garages aren't heated, but the houses are. And so, why heat the garage? And again, just really beautiful light-filled spaces. And she splurged on this giant 12-foot sliding door that went out onto the patio and faced the lake. Beautiful project. And then finally, the project that I've just completed earlier this summer. This is the Castlegar Chamber of Commerce, one of the first projects in Canada, maybe a handful, to combine Passive House with mass timber. And Tammy Verrigan-Burke, a visionary CEO at the Chamber of Commerce, just drove this project. We worked with her for close to 5 years to try to get to solution. And finally, Clean BC came out with a grant, and we applied for the grant using Passive House as the grant vehicle. And we're successful. And the beautiful thing about that is when we came time to value engineer, which you always have to value engineer, because it's certified passive house, you can't cut any of the very core aspects of the building. So we ended up losing some fancy acoustic treatment and some other kind of bells and whistles, but we were able to keep the architecture, we were able to keep the systems. It sits on the site in kind of an interesting way. You know, this is the sun path, and because of that, we ended up with the pop-up windows, which are really part of the energy system. The floor plan itself is a very small second floor where the mechanical system is, keep it out of the weather, and then the very large spaces are the public zones with offices around them. This is just a quick shot of the foundation. It's got a slab-on grade foundation to reduce embodied carbon, because normally we would do a 2 or 3 foot deep strip footing with a frost wall and then pour our slab on top of that. And so we were able to cut the amount of concrete used by, I don't actually have it quantified, we're working on that, but it's probably about 35% concrete, less concrete used. And then that orange is the insulation wrapping all the way around it to fully separate it from the environment. This is the mass timber going up on site. Mass timber is a beautiful product. The whole structure with the roof went up in about a month. And so we went from concrete to dry in a month. And typically with a hand framed structure, that would have been, potentially 6 months, which reduces labor costs. Some shots of the interior as we're putting it together. This is the Gore-Tex, it's not actually Gore-Tex, but this is the membrane on the outside that creates that air barrier, and you can see how careful we need to be in terms of, sealing every single penetration so that we end up beating that air change threshold. And we got down to 0.45. The passive house threshold's 0.6. My own house, actually, we hit 0.2. Step code mandates 1 at best. And so, but we can hit 0.4 no problem. And the tighter it is, the longer the building lasts, the less energy you burn. And it's not really an issue. This is foam insulation on the outside, which I'm not super proud of. I don't like foam, but it was a cost-cutting measure, and it did meet all of the other metrics, and it let the project go forward. So we ended up having to use it. I'm a big fan of cellulose, post-consumer recycled content, etc. We did the blower door test. Like I said, we hit 0.45. And there's the project finished on site, and it's under use right now. It's a beautiful building. I'm very proud of it, actually. And I think hopefully it sets a bit of an example for how we can approach the built environment regionally going forward into the future. I encourage all of you to go and visit it. It's a beautiful building. And we'll stop with these beautiful lantern shots on the outside. Thank you very much.